guys, it's Mrs. Tremblay, lesson 9.1, solving quadratics by graphing. I'm sure we've discussed in class the fact that you have already been solving quadratics without even knowing it. You've been solving quadratic equations by factoring, because right here, this ax squared plus bx plus c equals 0, that is the equation you've been factoring in the polynomial unit. This is also the standard form of a quadratic equation. So this unit, we're going to look at several ways to solve a quadratic equation. One of them, yes, it's factoring. Using the factor sum chart or the window method you've learned, you can actually solve these by graphing as well. Because the solutions to a quadratic are actually the x-intercepts. So on a graph, you can locate where the graph touches the x-axis. That's where the answers are. So the solutions can be referred to, of course, as solutions. They're also called roots. And x-intercepts, we just said. And I might also ask you, what are the zeros of the function? When I say zeros, I'm talking about when x is 0. I'm sorry, when y is 0, what x is. So those are the 3 ways I might ask you for an answer, or actually 4 with the roots. And you saw before, when you did your factor sum charts, many times you got 2 answers. You got x equals, right? There were times when you got 1 real solution, right? Do you remember getting like a quantity of x plus 1 squared, and when you set that equal to 0, x ended up being the same thing twice, right? So that's 1 real solution. And today you'll see that sometimes there are no real solutions. Sometimes the graph doesn't touch the x-axis. So x-intercepts are solutions. One way to solve a quadratic is by factoring. Another way that we're going to learn today is by graphing. So let's do it. I'm going to show you how to do this the long way first, and then we'll shortcut it with the calculator. So if you don't have your calculator, you're definitely going to want to have your calculator today. So hit pause, go get it. Welcome back. Okay, first thing that you should do, it's kind of like y equals mx plus b. If you want to graph it, make sure it's in y equals mx plus b form. If you want to graph a quadratic, you need to make sure it's in ax plus bx plus c form and set equal to 0. Now over here, you might see the x and the y and be thinking, but where's the y? When this is set equal to 0, you kind of look at this as the y, or as the f of x, if you will, because you learn about function notation as well. So once you have it set equal to 0, you're good to go. Whatever you plug in for x, what comes out gives you your y. So I've picked some points for you to start. If I didn't pick some points for you, you would end up picking some points for yourself. I usually choose real friendly numbers to start with that would fit on whatever grid I'm given. So these are chosen. All right, so what I want to know is when x is -3, what y is. So I'm just going to take -3 and plug it into the equation. Please be careful when x is negative, right? We said that we have to wrap that up if we're going to square it, because the quantity of -3 squared is different than -3 squared, right? So if I want x to be -3, that means keep it together. Keep the negative with the 3 by using parentheses. All right, so wherever I see an x, I'm going to plug in a -3. So this is what it looks like. You don't need to type this in. The quantity of -3 squared is 9. 9 plus -6 is 3. And 3 minus 3, or 3 plus -3, is 0. So the ordered pair that we have here is -3, 0, which might be kind of hard to see. Why don't you throw a little x comma y up here, and we can list it out. So -3, 0. That's our first ordered pair. So we got 1 point down, 4 more to go. Right, plug in a -2 into this equation. Find out what you get for y. All right, so I have 4 plus -4, that's 0, and 0 plus -3 is -3. So for my next ordered pair, I have -2, -3. All right, plug in a -1. Hopefully you're just cruising along, solving this out. So I have 1 plus -2, which is -1, and -1 plus -3 is -4. See those integer rules, how important they are. You make things go so much faster by knowing them. I didn't put this in parentheses because if I square 0, it doesn't really do anything by having those parentheses. That only matters when I have that negative base. All right, so 0 plus 0 is 0, plus -3 is -3. Yes, it's okay to have the same one again. You'll see that's very important in a quadratic to have the same y value again. And last but not least, and again, I'm not putting that 1 in parentheses. I can if I want, but I'm too lazy for that. That's me. I'm lazy. It's like 5 in the morning and I'm recording lessons in my basement. But yet I'm too lazy to write parentheses around that. It's crazy. All right, 1 plus 2, that's 3. 3 plus negative 3, oh, it's 0 again. So my ordered pair would be 1, 0. All right, when you're trying to graph a quadratic, we know that it's supposed to be in the shape of a parabola. We've already seen that during class. And with that parabola, we have a vertex, and then we have points on either side that are kind of a reflection over that line of symmetry, right? So when you're looking at this, you see how this negative 4 happens the one time, and then the same values are happening from the inside out. That's my vertex. That's how you can locate the vertex. And when you're trying to graph it, you basically want the vertex, and I would suggest having 2 points on either side for 5 points total. That gives you a nice shape of the graph. So let's plot these points. I have negative 3, 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, and 0, 1. Or sorry, 1, 0. All right, this is the hard part for me. I'm going to draw a smooth curve, not a V, because a V is going to be absolute value. I want a U-shaped parabola here. This is what it looks like. Now you might be thinking, yay, I'm all done. We're not, because wasn't our goal to solve this? Okay, so when looking at a graph, if I gave you this graph and said, what are the solutions, you would look at where does this graph touch the x-axis, because those are considered the solutions. So up here where we said a quadratic can have 2 real solutions, 1 real solution, or no real solutions, this one has 2 real solutions because it hits the x-axis twice. One of those solutions is when x is 1 to negative 3, and the other solution is when x is 1. In looking at the table, we can also tell that those are the solution points because those are the 2 times when y equals 0. And when y equals 0, that's how we get our little x-intercepts. Okay? So in looking at a graph where it touches the x-axis, those are the solutions. You can have 2 solutions, 1 solution, 0 solutions, and I'll show you what all of those look like. Okay, so now at this point, I'm sure that if I had you generate your own table by hand, you could do that. Now I'd like to pick up the pace a little bit because we're already like almost 7.5 minutes in, and I want to wrap this up. I want to make like a present and wrap it up. So take a look. We're going to use our graphing calculators now to generate a table instead of us generating a table. It'll be nice. Okay, in looking at this, I can't just go straight to my graphing calculator because this is not in standard form. It needs to be. So your first job is to get all these terms on one side and have 0 on the other. I would move this negative 16 to here because there's already 2 terms there. So to cancel out that negative 16, I'm going to add a positive 16. Over here, I'm left with x squared minus 8x plus 16. And negative 16 plus 16, additive inverse, of course, equals nothing. Because when you add opposites, you get nothing. Okay. Right here, x squared minus 8x plus 16, that's my equation. And remember, this is kind of like the y. So get your calculator, turn it on. Oop, I had an old graph on here from before. Isn't it pretty? Okay, go to y equals. Actually, I'm going to do a second plus 7, 1, 2, because I have been messing with this all morning. Okay, back to business. So step 1, just like when you wanted to graph a linear equation, you went to y equals and typed in the equation. We're going to do the same thing. Press y equals. Try to get this where there's not a glare. All right, and now you want to type in x squared. And maybe some of you are going to type in plus negative 8x. Same thing. And then plus 16. Okay, want to see what it looks like first? Go ahead. Okay, press graph. Okay, that is what it looks like. Nice U shape. It's kind of hard to tell right here. Are there 2 x-intercepts? Are there 1? What's going on here? But I might look at this. I would probably hit graph first and then look, okay, about where does it look like my x-intercepts are? So when I'm choosing my points, I'm choosing points that I can see the graph of. So when I look, it looks like 1, 2, 3, 4, like x is about 4 right here. So when I go to my table, go to your table, press the second graph. I want to look at when x is 4. Right on. That's the vertex. And it's the solution. Wow. I can tell it's a vertex because see how the 0 appears once, and then I have the same number on either side and the same number on either side again. Yes, that's how we can tell. And also, the x-intercept happens when when y is 0. So I am going to list a table on my paper, and you should too. You should always do that for me so I can see, do they know what they're doing? Was it just a silly little mistake, or did they use all the wrong values? What's going on? So in this, I said I like to have the vertex and 2 points on either side. So here's the vertex, 2 points on either side means I want to know when x is 2, when x is 3, 4, 5, and 6. So those are the values I'll use for my table. And I can see in here when x is 2, y is 4, 3 it's 1, 4 it's 0, and then I have a 1 and I have a 4 again. That was a lot easier, wasn't it? But if you had to plug values in for the x, I know that you could do that. It's just these calculators are such a useful tool, and they make things go by a lot faster. And when you're taking your Explorer and you have 30 seconds a question, you'll thank me. All right, here we go. Let's plot these. 2, 4. So again, these are just like my little ordered pairs right here now. So over 2, up 4. Over 3, up 1. 4, 0, 5, 1, and 6, 4. All right, make your smooth curve. And we have our lovely little parabola, and now you can kind of see this is what happens when there's one real solution. There are imaginary solutions that you will cover in Algebra 2. For now, we're only dealing with the real ones, not the imaginary. And I'm being totally serious. There are imaginary solutions. Just wait. I wish I taught Algebra 2 so I could talk all about imaginary numbers. Anyway, right here, it hits the x-axis once. That means that that's my only solution. So solution to this one is x equals 1, 2, 3, 4. Just one solution. All right. Switch my paper on over here. Here we go. This is the last one of this, and then we have a little story, of course, in the back for you. So exciting. Okay, not standard form, right? What I would do in this one, I would move the negative x squared term to this side instead of moving this one and this one. It doesn't matter, and I'll show you at the end what would have happened if we didn't choose to do that, just in case you're thinking, well, wait, doesn't the negative 1 make a big difference? It doesn't with when you're solving it by graphing. So take a look. I'm going to add x squared, those are gone. So 0 equals, and in standard form that x squared gets to go first, then 4x, then the 5. Okay, if you wanted to take a minute and try to do a factor sum for that chart, maybe, our factor sum chart for that, maybe I've already made you do that, one of my crazy little starters, you'd have a rough time making this one happen. That's all I'm saying. Okay, so we want to go ahead and graph this. I'm going to use my calculator feature, go to y equals, and our equation that we want is x squared. And whatever letters, you know, sometimes I don't use x, and we all want to write x anyway. If it's not x, you can still use x on your calculator. If this was like p squared plus 4p plus 5, you can still use x. It doesn't matter. So I have x squared plus 4x plus 5. I'm going to hit graph just to kind of check it out so I know where I'm searching in my table. Oh, well, look at this. Where does this graph touch the x-axis? It doesn't, does it? It comes pretty close. It looks like it comes pretty close when x is about -2. Now, I still want to graph this on paper, but this is what no solutions would look like. It's not ever going to hit the x-axis here. It's not possible because the the lowest point on this graph is when y is 1, and y can only be greater than or equal to 1. It can't be less than 1. Okay? So go to your table, and I'm going to start off, I want to look at about when, you know, x is -2. And I see when x is -2, that's where the vertex takes place. And I recommended that you graph the vertex and then 2 points on either side. So when I list my table, I'm going to list when x is -4 all the way to when x is 0. So over here, let's draw our little rough table. I said go from -4 to 0, and then just list the corresponding y values for that. So when x is -4, y is 5, and then you have 2, 1, 2, 5. So we can see there's our vertex right here, and then we have those same inside out y values. All right, let's plot -4, 1, 2, 3, 4, and then +5, 2, 4, 5, and -3 and 2, and then we have -2 and 1, negative 1 and 2, and now it's just going to be a little reflection. Connect them with a smooth curve. And there's our parabola, and you can see this thing is never going to touch the x-axis. Ever. It's not possible for this graph to touch it. Can't touch this. MC Hammer, that's what he wrote the song about. It was about this graph right here. It was a no solution quadratic. Ask him about it sometime. Sure. Like, my math teacher makes stuff up all the time. Is this one true? And he'll say, nope, it's not. Alright, anyway, I would classify this as no real solution. And you might be thinking, do I have to write the word real? Yes, because I told you there can be imaginary ones. Not just ones I make up, but really imaginary solutions. I will let you write NRS, but in your notes you should have no real solutions so you know what NRS means. It's not a nurse. You don't need a doctor for the quadratic. There we go. So no real solutions. Now I told you that it would be okay if you decided to move those other terms to the other side and graph it. And I'll just show you this. You don't have to write this part, but let me just show you. If you would have chosen to move those terms to the other side, you would have ended up with a negative x squared minus 4x minus 5 equals 0. And if I were to graph that equation, so again, it was negative x squared, let me just clear this one out. Negative x squared minus 4x minus 5. If I graph that, I can see that, there we go. Yes, the parabola opens down instead, but is that parabola ever going to get to touch the x-axis? No. So if you're solving this from a graph, it doesn't matter if it's opened up or opened down, it's still going to be no real solution. So if I'm asking you to solve it, the solutions are still the same. There aren't any, because it's never going to be able to touch the x-axis. Alright, so you've seen when there's 2 solutions, you've seen when there's 1 solution, you've seen when there are 0 solutions. Now you need a story. It's story time. This is a football story, a sports story. There's a football kicker. Once upon a time, there was a football kicker. And he kicks a football 2 feet above the ground with an upward velocity of 75 feet per second. The function h equals negative 16t squared plus 75t plus 2 gives the height h in feet after t seconds. After how many seconds is the football 50 feet above the ground? Maybe you're thinking, what kind of story is this? This would stress me out if I read this right before I went to sleep. I don't want this to stress you out. This isn't really that big of a deal, to be quite honest with you. They just give you a lot of information. So it tells you that the football kicker kicks the football 2 feet above the ground with an upward velocity of 75 feet per second. And then it tells you the equation that represents it. So you don't need that whole first sentence, because the whole first sentence is how that equation was generated. And you don't have to generate the equation. Lovely. So this right here, it says gives a height in feet, and then t is time. So we know what our variables represent. The question is, after how many seconds is the football 50 feet above the ground? So when I say after how many seconds, that means you're looking for t, which really means you're looking for the zeros of this function, or you're looking for the x-intercepts, or the roots, or the solutions, all those different ways. And it gives you a height of 50 feet. So after how many seconds is the football 50 feet above the ground? And we said that h represents feet. So all you really have to do to solve this is plug 50 in for h and figure out what the value of t would be. So this is what I'm saying. Put 50 in for the height, because I'm giving you the height. I want to know after how many seconds is it 50 feet above the ground? So you're given h. We're just looking for t. It's tea time. No, it's coffee time. I've got my coffee going. I'm going to take a sip right now. Yep. Ah, much better. It's not Diet Coke, but, you know, it's like 6 in the morning. So, here we go. I can't solve this the way it is, right? You need it to be ax squared plus bx plus c form, and this 50 is not going to work. So, step 2 actually, because first we plugged it in. Get rid of that 50. And some of you wrote minus 50, and some of you wrote plus negative 50. Same thing. That's gone. So 0 equals negative 16t squared plus 75t, and then 2 plus negative 50, those are the only like terms, gives me a negative 48. Or if you wrote minus 48, fine. Okay, aren't you glad you don't need to use the window on this one? I know, that might take you a little bit of time. Let's do what we did before with our calculator. Go to the calculator, press y equals. So now that you have this lovely tool, this is what I would do. And I don't give you a graph. I'm expecting you to fully solve this one on your calculator, because we're going to have some decimal numbers that aren't friendly on this one, and I want you to be able to use this. So negative 16, and instead of putting a t, I'm going to put an x, just because it's easier than trying to locate the t. You could if you wanted, but x is just a little bit easier. And then I have plus 75, and I'm going to use an x. And remember, it was plus negative 48 or minus 48. Now hit graph to give you an idea of what you're looking for. Okay, when I look at this graph, to me it looks like x is 1 and x is 4. And maybe you're thinking, well, wait a minute, how can there be two answers? I'm trying to figure out how many seconds the football was 50 feet above the ground. How can it happen twice? Well, remember that little saying, what goes up must come down. So when it's on its way up, it's going to reach a height of 50 and then curve around. And when it's on its way down, it's going to reach a height of 50 again. So yes, it can happen twice. We're looking for 2. So if it looks like when x is 1 and x is 4, I'm going to check my table to see if it's that easy. To check my table, remember you press second, graph. And I see that when x is 1, y is not 0. And when x is 4, y is not 0. So those aren't my actual solutions. I'm going to hit graph again. All right, so what on earth are we supposed to do here, right? This is where your calculator is so awesome. I mean, it's awesome all the time, but now it's even more awesome. Go to your calc feature. To get to calc, it's right above the, see the word calc above the word trace? Press second trace. Okay, now this is so nice. Do you remember all the words that can be used to find the solutions? Yeah, we had roots, we had solutions, we had x-intercepts. Didn't we have that word zeros as well? Yep, and look at this will even find your maximum and minimum if you want, and we will use it for that. So it can find your vertex, but right now I'm concerned with the zeros. I want the solution. So hit the down arrow, go to 0, hit enter. And now, maybe this looks familiar because we've done this with linear functions. It says left bound. This is where you want to click to the left of the x-intercept and the y. I'm sorry, left and right of the x-intercept. Hit enter twice. It'll tell you. We're going to do it twice though. So I don't see the little blinking spider, and it says here that x is 0. So the spider is wherever x is 0, so I'm guessing it's down here somewhere. So hit your right arrow until you see your little spider. There he is. Oop, he went too far. So go back, hit your left arrow, and we're using right and left arrows with this. So right now I'm to the left of this x-intercept, and it says left bound. Yes, hit enter. Now I want to get right bound, so I'm going to hit my spider to the right one time. Don't smash it, just hit it. Okay, now it says guess question mark. You do want it to guess, so hit enter again. And there we go. So the reason we couldn't find it in the table is because the table gives us whole number amounts, right? So it looks like about 8/10 of a second if I was going to round to the tenths place. So that's one of them. X equals about 8/10. So here I'm going to say t is about equal to 8/10 of a second. So after 8/10 of a second, that's the first time. Now it happens again because what goes up must come down. And I want to find this one now. So I'm going to do the same thing. I'm going to press second trace. I want to find the 0. This time I need to get to the left of this. So I kind of want to be above it. So hit your right arrow until we're above it. It's taking a while because the maximum height must be pretty high. Oh, too far. Bring your spider back. Okay, now it's to the left of the point. So hit enter. Now get it to the right of it. Hit enter. To get it to guess, hit enter again. And it says x is 3.92, so I would say that's about 4 seconds. So t is about 4 seconds. So as a football player throws it, after almost a second, it reaches 50, and then it's up in the air for a couple more seconds, almost 3 seconds, and then as it comes back down, after 4 seconds, 50 feet again. All right, you're done. See you tomorrow.